Chapter Acids. Formation of formic acid by the oxidation of methyl alcohol. Place in a 100 centiliters distilling flask 5 grams of powdered potassium bichromate to 20 centiliters of water and 5 centiliters of concentrated sulfuric acid. Cool the flask and add slowly with shaking 2 centiliters of methyl alcohol drop by drop, keeping the flask under water. Place the flask for about 10 minutes in a beaker containing boiling water. Distill off using a condenser about 10 centiliters of liquid. Apply to the distillate. Tests described in experiment above and write the equation for reaction involved. Preparation of formic acid from oxalic acid. Into a 215 centiliters distilling flask provided with a condenser and receiver, put 20 grams of anhydrous glycerol and 20 grams of oxalic acid. Close the flask by a cork carrying a thermometer which is so placed that the bulb is below the surface of the glycerol. Heat cautiously with a small flame. Carbon dioxide is given off at about 18 degrees. Maintain the temperature at 105 degrees circa until the evolution of gas has slackened. Cool the contents of the flask to about 16 degrees. Add 20 grams more of oxalic acid and beat as before. And heat as before, repeat the addition of oxalic acid until 18 grams in all of the acid have been used. After the last portion of the acid has been added, allow the temperature to rise to 115 degrees. A dilute equation, a solution of formic acid is obtained. Properties of formic acid. Odor of formic acid. Know the odor of the solution obtained in experiment 18.6 and test the solution with blue litmus paper. As far as concerns the reduction of silver formate, neutralize 2 centiliters of the dilute solution of formic acid with ammonia and add a few drops of a solution of silver nitrate and warm carefully. Reduction of mercuric formate. Shake for about 1 minute 2 centiliters of the distillate with 0.2 grams of mercury oxide. Filter the solution and heat it to boiling. The mercuric formate first formed is reduced to mercurose formate and finally to mercury. This is a valuable test for formic acid. Reduction of mercury chloride by formic acid. For the reduction of mercury chloride by formic acid, you to 5 centiliters of the distillate I add 2 centiliters of a solution of mercury chloride and heat the solution. So the mercury chloride is reduced to mercurose chloride. Decomposition of formic acid by sulfuric acid. To see the composition of formic acid by sulfuric acid, to 2 centiliters of distillate add 2 centiliters of concentrated sulfuric acid slowly and heat gently. Apply flame to the liberated gas, and if an inflammable gas is not obtained, repeat using 0.5 gram of sodium formate. Oxidation of a formate. Neutralize 1 centiliter of the distillate with a dilute solution of sodium hydrate. Add drop by drop a dilute rose-colored solution of potassium permanganate. What is the significance? And write the question: what is the significance of the result when compared with the action of unsaturated hydrocarbons with potassium permanganate? Salts of formic acid. Dilute what is left of the distillate with an equal volume of water and divide it into 2 portions. Boil one for about 5 minutes with an excess of lead oxide and the other with the copper oxide filtered solutions while still hot and set aside to crystallize. Formation of acetic acid from ethyl alcohol. To 15 grams of coarsely powdered potassium bichromate contained in a 200 centiliters round bottomed flask, add a mixture of 15 grams of concentrated sulfuric acid and 10 centiliters of water. Set the flask on a sand bath and connect it with a reflux condenser through which a rapid stream of water is passing. Add throughout the condenser slowly in portion of 0.5 centiliters, 3 centiliters of alcohol. Shake after each addition and wait until the vigorous reaction which takes place subsides before another addition of alcohol is made. When all the alcohol has been added, heat to boiling for 15 minutes. Change the condenser and distill off about 10 centiliters. Observe the odor of the solution and test it for acetic acid by experiment 91 and B. 91A and B. See below. Note that dark is usually present in the distillate ethyl acetate and aldehyde, both of which have a characteristic odor. Noted a mixture oxidizing agent to use in the preparation of acetic acid by oxidation, since acetic acid and is not readily oxidized by formic acid. Preparation of glacial acetic acid. Melt cautiously in an iron dish about 15 grams of anhydrous sodium acetate. Grind the salt to a coarse powder in a mortar. Weight 14 grams of the salt and place it in a 200 centiliters flask. Add cautiously throughout a funnel, keeping the flask cold by immersion in water. 25 centiliters of concentrated sulfuric acid. Place a thermometer in the flask in order to determine the temperature of the vapor. Connect with a condenser and receiver and distill off the acetic acid. Weight the acid obtained. Calculate the theoretical amount which can be obtained from 14 grams of sodium acetate and the percentage yield of the experiment. Glacial acetic acid causes painful blisters when left in contact with the skin. Properties of acetic acid. Solubility of acetic acid. Test the solubility of acetic acid in water, alcohol, ether, and benzene. Place about 10 centiliters of the acid obtained in a test tube surrounded by chipped ice and water. Insert a thermometer into the acid. If crystals do not form, scrape the side of the tube with a glass rod. If the acid freezes, remove the tube, stir with the thermometer and note the temperature when the acid is about 1/4 melted. Pure acetic acid melts at 16.70 degrees and boils at 119 degrees. 1% of water lowers the melting point about 2.1 degrees. Acetic acid and oxidizing agents. Determine whether acetic acid reduces solution of potassium permanganate, silver nitrate, and mercuric chloride. Compare the results with those obtained with formic acid of experiment 87, page 64. Add a few crystals of formic acid to a mixture of 5 centiliters of glacial acetic acid and 2 centiliters of water. Heat boiling. Is the chromic acid reduced? Formation of verdigris. Stand a piece of copper foil in a small beaker containing acetic acid. A part of the foil should be under the liquid and a part exposed to the air. Examine the foil at the next exercise. What is formed? Tests for acetic acid. Formation of basic ferric acetate. Add a few drops of solution of ferric chloride to solution of sodium acetate. Note the color. Heat the solution to boiling. The natural ferric acetate is converted into a basic acetate ready equation. In using this test for the free acid, it must first be neutralized with sodium hydroxide, formation of ethyl acetate. For formation of ethyl acetate, we repeat the test involving the formation of ethyl acetate given in experiment 18.1 at page 59. For conservation of acetic acid into acetaldehyde, place in a dry test tube 0.6 gram of anhydrous sodium acetate, 0.2 and 5 centiliters of concentrated sulfuric acid, 1 centiliter of aniline. The substances used should be measured accurately. Close the mouth of the tube with a cork bearing a piece of glass tubing about 2 feet long. Support the tube in a vertical position and heat it so the contents boil gently for about 1 hour. Cool. Dissolve the product in 25 centiliters of boiling water. Filter hot and set aside to crystallize. Determine the melting point of the crystals. Acetanilide melts at 116 degrees. The identification of a substance is best accomplished by converting it into a solid which has a definite melting point and can be readily purified. In the case of acetic acid and its homologues, the anilides serve this purpose well. They are formed as a result of the elimination of water from the acid and aniline. CH3COOH plus C6H5NH2 gives as a result CH3CO and H6H5 plus water. If the acid to be identified is dissolved in water, it is neutralized with sodium hydroxide and the solution evaporated to dryness. The salt is cautiously heated over a free flame to drive out the water of crystallization. It is then heated with the aniline and enough concentrated sulfuric acid to set free the organic acid. When salts are used, the reaction is as follows: CH3COO and sodium plus C6H5 and H2SO4 gives CH5CONHC6H5 plus sodium SO4, sodium sulfurate, plus water. Preparation and properties of soap, saponification of fat. Weight 3-5 grams of lard in a small beaker and add slowly with constant stirring 9 grams of sodium hydroxide dissolved in 9 centiliters of water. Rest the beaker in a second beaker containing boiling water and heat the mixture in this way for from 5 to 16 minutes. Stir the mixture occasionally until it hardens, and the chief constituents of lard are glyceryl esters of palmitic, stearic, and oleic acids. Right equations for the reaction would take place when these three substances are heated with sodium hydroxide. Test for free alkali in soap. Determine whether the soap prepared in the above experiment contains free alkali as follows. Dissolve a small piece of the soap in cold water and test the solution with the solution of phenolphthalein. Hydrolyze of soap. Shake vigorously a piece of ivory soap about the size of a large pea with 10 centiliters of cold water. Filter and test 1/2 of the solution with the solution of phenolphthalein. How do you explain the difference between the result of the experiment and that obtained with the soap you prepared? Heat the boiling the other half of the solution of our soap and add phenolphthalein. Explain right equation for this reaction. Soft soap. Cut the soap you prepared into the shaving legs. Heat it with 400 centiliters of water until it dissolves. Divide the product into 4 parts. Put aside one of these and allow it to cool. Describe the properties of the soap. Salting out of soap. Precipitate one portion of the solution by adding slowly with stirring an equal volume of unsaturated salt solution. Filter off the precipitate and save the filtrate for another experiment. Wash the precipitate with 15 centiliters of saturated salt solution. Let it drain through outly and finally spread it on a watch glass to dry. Test soap for free alkyls as below, as the experiment illustrate below. From what organic compound has the soap been separated by this treatment? Solubility of soap. Test the solubility of the purified soap in water, in alcohol and ether. This can be almost readily by shaking pieces of the soap with about 15 centiliters of each of the solvents, filtering and evaporating the solvent on a water bath. If there is any residue from the ether, test it to determine whether it is soap or fat which is not saponified. Action of hard water and soap. To determine the action of hard water on a solution of soap, add a small portion of solution prepared in above solution of calcium chloride and magnesium sulfate. Test the solubility of the precipitates in water. Explain the differences between the action of sodium chloride and calcium chloride on soap solution. Did you note any difference in the action of the two salts of dilute solution of soap? What chemical compounds may be present in natural hard water? Isolation of fatty acids from soap. To the remainder of the solution prepared above, add hydrochloric acid as long as a precipitate is formed. Of what does this precipitate consist? Write the equation, filter and wash with drop by drop solution of bromine in carbon tetrachloride. Write the equation. Identification of glycerol in the product of the hydrolysis of fat. The presence of glycerol can be shown as follows. Neutralize with dilute hydrochloric acid about 100 centiliters of the solution reserved in experiment above. Filter, evaporate the filtrate to dryness and stir the residue of salt and glycerol with about 20 centiliters of alcohol. Decant of the liquid throughout, filter and evaporate on the steam bath. A sample of impure glycerol will be left. Prove the presence of glycerol by applying 2 of the tests given in experiment 84. If one precipitation does not free the soap from alkali, redissolve it and precipitate again. Ether dissolve fat but does not dissolve soap. This solvent can be used, therefore. Fat but does not dissolve soap. This solvent can be used to determine the presence of unsaponified fat in a sample of soap. Preparation and properties of oxalic acid. Heat on the steam bath in an open 500 centiliters flask 120 grams of concentrated nitric acid and 20 grams of cane sugar. As soon as brown fumes begin to be evolved, place the flask in a hood and let it stand until the rapid evolution of oxide of nitrogen cheeses evaporate on the steam bath until the volume of the liquid is reduced to about 13 centiliters and set aside to crystallize. Filter off the acid throughout a funnel provided with a perforated plate. Using a filter paper, dissolve the crystals in the smallest amount of boiling water possible and set the solution aside to crystallize. Oxalic acid dissolved in 10.146 parts of water at 14.5 centimeters. Weigh the product obtained. Action of heat and oxalic acid. Heat about 1 gram of oxalic acid in a dry test tube. Continue the heating after the water of crystallization has been driven off. Describe the result. Oxalic acid 2 COOH for 2 water molecules. Every 2 water molecules melts at 99 degrees. The anhydrous acid sublimes at 118 degrees. Change of a formate to an oxalate. Heat in a dry test tube about 1 gram of sodium formate. Apply a flame to the gas involved. Test the residue for an oxalate according to experiment below. Potassium tetroxalate. Dissolve 5 grams of oxalic acid in 13 centiliters of hot water. Neutralize exactly 1/4 of this solution carefully with a solution of potassium hydroxide 1:4 in proportion 1:4, and combine the solution and set aside to crystallize. When cold, filter off the salt. Dissolve a little of the salt in water and try its effect on iron rust stain, also on a spot made with an iron ink and ink made from anilide dye. Potassium ferric oxalate. Add to a solution of ferric chloride a solution of potassium oxalate until a clear green solution is formed. Moisten a piece of paper with solution. Test the paper for a ferrous salt by passing on it a drop of potassium ferricyanide. Expose a piece of the paper to direct sunlight for 1 minute and test again for ferrous salt. Test for oxalic acid and oxalates. Oxalic acid and sulfuric acid. Heat about 2 grams of oxalic acid with about 5 centiliters of concentrated sulfuric acid. Write the equation per some of the gas formed into a test tube containing a solution of barium hydroxide and shake. Ignite the gas which is produced in the reaction. Output, you prepare carbon monoxide free from carbon dioxide by making use of this decomposition. What other acid yields carbon monoxide when heated with sulfuric acid? Silver oxalate. In a test tube, neutralize a solution of oxalic acid with ammonia. If a slight excess of ammonia is added, boil the solution until it is neutral to litmus. Cool and add a solution of silver nitrate. A precipitate of silver oxalate is formed. Heat to boiling. Compare the results with those obtained with formic acid of the experiment at page 64. Precipitation of calcium oxalate. To a solution of oxalic acid, add ammonia and slight excess and then a solution of calcium chloride. Write the equation. Test the solubility of the precipitate in a solution of acetic acid and dilute hydrochloric acid. How would calcium carbonate act when treated with acetic acid? Reducing action of oxalic acid. To a solution of oxalic acid or an oxalate, add dilute sulfuric acid and a solution of potassium permanganate. Equations. Repeat. Use a solution of potassium permanganate in place of one of potassium permanganate. Equation.